At the Northrop Grumman facilities in Baltimore, Maryland, a new technology is taking shape that will radically alter the face of airborne surveillance systems. In this video, we'll introduce you to MESA, the Multirole Electronically Scanned Array Surveillance Radar. Northrop Grumman began work on an electronically scanned 360-degree surveillance radar in the late 1980s. Because the development was on company funds and the Cold War was ending, an inexpensive solution was needed to help launch the product line. Northrop Grumman teamed with Boeing in 1996 to provide the MESA system on a 737. The advantage of electronically scanning as compared to mechanical scanning is that you can manage your radar energy to scan further in threat sectors than in safe sectors. You can also revisit targets of interest much more frequently than with a mechanical system, enabling faster and more accurate tracking. The 737 offered an inexpensive platform that was large enough to provide the required antenna size, as well as enough electrical power and mission range, giving an optimum cost solution for prospective customers. The decision by Australia in December 2000 made MESA a reality. The MESA system consists of two major segments, the cabin electronics and the antenna. In a first for airborne surveillance radar, the MESA antenna is itself aircraft structure. It consists of two side arrays and one top array, the top hat, that covers the forward and aft portions of the surveillance area via unique end-fire technology. All three arrays are built up from a series of complex composite manifolds. These manifolds are made of space-age foam material that is laminated with metal emitting array designs. By using special electronics, the radar energy is switched through the three arrays as required to achieve 360-degree radar and IFF surveillance. The side arrays manifolds are installed vertically, behind radome mounting surfaces accurate to within thousandths of an inch. These arrays provide 130 degrees of coverage to the left and right. The top hat end-fire array on top provides 50 degrees of both forward and aft surveillance. Altogether, Northrop Grumman invested over $5 million to set up the specialized antenna production facility. The antenna, over 35 feet long and 16 feet high, is carefully moved after final assembly via a specially created transport and test fixture. The antenna is checked on a production test range to ensure that all the components have been correctly installed. Mounted into the lower part of the antenna are critical avionics, such as the dorsal power supply and the antenna shifters that allow the unique integrated radar and IFF in the same antenna. The MESA antenna, especially its unique end-fire top hat array, represents the cutting edge in distributed aperture electronically scanned radar technology. It will revolutionize airborne surveillance in the 21st century. Of course, the antenna is only half the story. Equally important are the cabin electronics. Using manufacturing experts from the Massachusetts Institute of Technology, a reconfigurable manufacturing cell was created to allow development, test, and production efforts to occur simultaneously in a unified facility. Investing over $6 million, Northrop Grumman has combined the latest manufacturing philosophies, unique test equipment, and highly specialized personnel in one facility. This has shortened development time, minimized cost, and enhanced the quality of the delivered product. Large portions of the interior electronics are taken from commercial applications. This saves on cost and development time. This also helps solve the problem of parts obsolescence, as newer configurations of major components, such as the core computer, can be plugged in with minimal or no change in the main radar software. The software is a normal commercial product, allowing for standard training and easier modification. The segregation of software into discrete areas is the key in effectively utilizing the combination of commercial and design-specific electronics. Of course, the most important core technology and the heart of Northrop Grumman expertise is the combined transmit and receive module. The TR module is based on years of developmental research and represents extremely high power in a small volume. High automation and extensive quality control have produced a family of modules all exceeding their design specifications. They are packaged by the hundreds in each radar system. The combined power and individual controllability creates the power and flexibility needed in an electronically scanned airborne surveillance system. The major parts of the cabin electronics, the radar support cabinet, IFF support cabinet, the Mercury core computer, and the radar power supply, are all designed and packaged in a way to enhance the operation and support of the 737 AEW&C and MESA radar. The first full MESA system entered test at the Baltimore facility in the summer of 2004. Packaged in a $7 million upgrade to the Northrop Grumman test range, the integration facility works in conjunction with the flying test aircraft to create and improve the premier electronically scanned airborne surveillance array in the world today. The first MESA-equipped Boeing 737 completed U.S. Federal Aviation Administration's airworthiness testing in May 2005. High-power radar in-flight testing began in 2005. 2 aircraft are executing the airborne test and integration phase. This testing will validate the multiple beam control options originally envisioned for the MESA as far back as 1989, and confirm the complete integration of the MESA radar and AEW&C mission systems. With history driving us from behind, Northrop Grumman looks forward with Boeing to a successful program completion and the delivery to Australia in 2007 of the first MESA-equipped 737 AEW&C aircraft.